Hey guys, what's going on? We're talking about investigation 3.2, finding the longest factor string. And so yesterday we talked about the number 840. So if I flip back, remember we had this guy, right, 840, and we had to go through and figure out all the different factor strings. We found a lot. So today's building on that, and today it's how many unique prime factorizations of a number are there? So how many ways can we write the factors of a number, and are those unique? So that's what we're learning today. If you don't understand that, we're going to get into it right now. So what is an exponent? Well, an exponent is a symbol written next to a number. So like, it's not a symbol, it's a number. So let's say it was 5 to the second power. This right here is the exponent. So I'm just going to highlight that for you. And this is the exponent, okay? It's that little number. It's a small number written next to the bigger number, and what that is equal to is 5 times 5 equals 25. Now if I had 5 to the fourth power, that would be 5 times 5 times 5 times 5. And there's no shame to pulling out your phone or your calculator just to make sure you're right, because you're like 5 times 5, I think that's 625, but I'm not really sure, so it's 5 times 5 times 5 times 5. Boom! 625, I was right. So it's a small number written next to a mathematical number, or it can be written next to a letter as well. So it can be written, if I was going to write it here, it could be written like this, n to the third, right? That just means it's n times n times n, okay? It could also be written like in, if they had parentheses, like 6 plus 3 to the third power. So you do 6 plus 3 is 9 to the third power, which would be 9 times 9 times 9. So these are all the exponents, okay? That's really what it is. Exponents are those small numbers. Factorization of a number. Well, if I took the number 24, seems to be a good number that we like. Factorization, right, would be 2 times 12, and then 3 times 4, and then 2 times 2. Factorization is breaking the number down. Prime factorization is going down. So this would be factorization here. 24 could be 6 times 4. 24 could be 3 times 8. Prime factorization is when we circle the ending of all, when we can't get those numbers anymore. So for 24, right, it's going to be 2 times 12, 2 times 6, and 2 times 3. That's the prime factorization of 24. And I'm going to circle those prime numbers. Remember, 2 is prime. And we're going to write them from small numbers to big numbers. And it's going to be 2 times 2 times 2 times 3. And if you're looking at this and you're like, Mr. Cox, this looks very similar to what this is, right? Like these 3 numbers right here. So how many 2's do I have? I have 1, 2, 3. So I could write like this, 2 to the third, that means the exponent, and we're just going to put the little dot, which means multiply, times 3, and that's the same equation. So that equals 24. Alright, so moving down here, we have expanded form versus exponential form. So they're showing you, here is expanded form, okay? Here is, let me highlight this for you, maybe this will help. This is expanded form. Okay, and let me highlight exponential form. It's going to be like this. Okay, very easy. So what you're going to do for expanded form, you're going to write it all the way out, like 3 times 3 times 2 times 2 times 2. Exponential form is going to be 2 to the 1, 2 to the third power times 1 times 3 to the second power. Okay? Expanded form here, how many 7s are there? How many 5s? You write them in order from least to greatest, exponential. And over here, they want you to use these ones. So how many 2's are there? Well, you're going to write how many 2's that exponent says. There's 1, 2, 3, and then how many 5's. So go ahead and do that. Pause the video, do those few problems, and then start it up again. I'll show you the answers. I realized that I put a 3 there, so that's my bad. There were 3 2's and my brain just went that way. So here's the answers, right? So if I'm talking about, I guess I should go number 2 first. How many 5's do I have to write? Well, it's 5 to the 4th power, which means I need to write 5 4 times. So it's times 5 times 5 times 5 times 5. And 2 needs to be written 3 times, times 2 times 2 times 2. Same thing down here. How many 5's are there? There's 2. 5 to the 2nd, and there's 4 7's. 7 to the 4th. 7 times 4. 7 times 7 times 7. Not 7 times 4. They're very different answers. And the last one, you have 2 times 2 times 3 times 3 times 3 times 11 times 11. So there you go. Those are those answers. If you, how would you describe the process of breaking starting at 840? Well, for most of you guys, you thought of two numbers that made 840. Maybe it was like 84 and 10, or maybe it was 42 and 20. Maybe it was 2 times 420. Whatever it was, we broke it down. That's factoring down. That's factorization of 840. When you break down a number, how do you know that you cannot go any further? Well, when we get to the prime numbers, okay? That's how we know we cannot go any further. Prime numbers are at their smallest state. And then which factorization of 2500 is the prime factorization? So that doesn't mean anything. Don't worry about that. I'll do that on the video. So now I want you to find the prime factorization of 36. So go ahead and find the prime factorization of 36. We're going to do 2, right? We're going to put 36 right here and 36 right here. And you're going to show me two different sets of factoring down. So like maybe you're going to pick 6 times 6, and you're going to pick something else that makes 36. So go ahead and factor that all the way down to prime numbers, okay? So we're going to factor both these numbers all the way down to prime. So go ahead and do that, and then turn the video back on. Alright, so I picked 6 and 6 and 9 and 4. Maybe you picked 18 and 2. Maybe you picked 12 and 3. Whatever. They're all going to end in the same thing. So I have two 2's. So expanded form, remember that looks like this up here. It's a long way of writing it. We're going to organize it from left to right, small to big. Okay, in exponential form is how many 2's do I have? I have 2 to the power of 2, exponent 2, and I have 2 3's. So I'm going to put that little guy there. So those are equal equation or things, right? And so then it says choose a factor pair of 36 and show how the factor pair can be found in the prime factor. So that's a huge way of saying that they want you. I'm going to highlight 3 of these, okay? 1, 2, and 3, and I'm going to multiply those together. So I have 2 times 3 is 6, times 2 is 12, and then what's left over is this 3, right? So I'm going to multiply by 3, and you get 36. And then I'm going to pick a different 2 to put together. So let me just do this one and this one are going to go together. So 3 times 2 is 6. I can highlight this and make it a little bit more color-coded. Okay. And then I'm going to take the other 2 that are left over, the 3 and the 2, and I'm going to multiply those together, and it's going to be 6 again. Okay. And then you're going to see that it makes 36. So what they're saying is that you can rearrange all of these little prime factors, and you can find every number that multiplies evenly into 36. So you can rearrange all these prime factors into different formations, and they're going to equal 36. So that's what they're talking about here. How can you use the prime factorization of 36 to find all the factor pairs? So go ahead and write something there. I'll talk about more of that at 12. Okay, so I'm on the back side. Use prime factorization of 36 to find all of its factors. So that's what we're going to do here. And then over here, we're going to find a multiple of 36. So I'm going to tell you that's going to be 72. Okay, so go ahead and see if you can figure out all the factors of 36 using the prime factorization method. If you don't know, just keep watching. I'll show you. So you might be wondering what that means. Well, that means take like the first number, 2, excuse me, and then I'm going to put these 3 numbers together. So 2 times 3 is 6, and 6 times 3 is 18. And I'm going to put the 2 again in the front, right? And I'm going to say, actually I'm going to say, sorry, not the 2 in the front. I'm going to combine the first 2 numbers. So 2 times 2 is 4, and 3 times 3 is 9. So what they're asking you to do is combine these in all different ways and see if you can get all the factors here, okay? So keep doing that, see if you can get a list. I'll show you in a minute. All right, so I had the 4, which was 2 times 2. That's how I got the 4 here. And then 3 times 3 made 9. And then I went 2 times 2 is 4 times 3. 4 times 3 is 12. I have a 3 left over. And then I went the 2 and the 3 make 6. And this 2 and this 3 make 6. Now for 72, the prime factorization, go ahead and do the prime factorization of 72. And you might start off with 2 times 36. Circle that. And maybe you have 4 times 9, okay, and then you get down to the primes up to there. You have 2 times 2 times 3 times 3. We're going to circle those primes, and I'm going to combine like terms, so it's going to be 2 times 2 times 2 times 3 times 3. And for this question here, what do you notice about the prime factorization of the multiple? So this is 2 times 2 times 3 times 3. This is 2 times 2 times 2 times 3 times 3. What's similar between these two? And you're going to put that answer right there. Go ahead and do that. Okay, down here, so it's the same numbers as this, but hasn't added 2. So we haven't added 2 with it. So down here, write the prime factorization of each number below using exponents. So here we go. 2 times 5. Can't use any exponents there. This is going to be not 2 times 50, sure we could do that. 2 times 25 and 5 times 5. So I have 1, 2, 3, so I have 2 to the second times 5 to the second. Okay, so you're going to keep going and see if you can continue on. See if you can do the exponential form of 1,000 and then 10,000. Seems big, but it's really not. Okay, so it's 2 times 5 makes 10. 2 to the second times 5 to the second make 100. 2 to the third times 5 to the third make 1,000. Something's going on here. Think about the patterns sorry, of the 2's here and 100, 3's and 1,000. Can you make a prediction of what would come next over here and see if you can make that prediction? Good luck. So here's the big idea, okay? So 2 times 5 makes 10, 2 times 5 makes 10, but they're saying add 2 zeros. 2 times 5 makes 10, add 3 zeros. 2 times 5 makes 10, add 4 zeros, and we could go on and on and on. But we come down here, and basically what they're saying is that if you have 10 by itself, it could be 10 to the first power, that's 1 zero. 10 to the second is 2 zeros, 10 to the third is 3 zeros, 10 to the fourth is 4 zeros. So now they're saying, what about 270? 10 times what is 270? So I know it's going to be 27. I'm going to factor that as, what is that, 3 times 9? So it's going to be 3 to the 1, 2, third power, and I need to go up to 100,000. So how would I show 100,000? This is 10,000. So it's going to be 10. And to what power? You're going to put it in right there. So think about that. Pause it for a minute. Make your guess. Okay, we're back. It's 10 to the 5th power. All right, so I'm going to go ahead and pause the video here, post it, and then I'll finish these last few questions with us in class so that you have something to do. I'll talk to you guys in a bit.